For this problem, we're given some data about responding to the question, if ever married, how old were you when first married? And then over here we have a 90% confidence interval. Part A asks for the mean, x bar. Actually, it's stated right here as 23.650. So I'm going to go ahead and enter that in. But also, this number is in the middle, it's in the center of this interval. So like one way to compute this number would be to add up these two numbers and divide by 2. It would give you the average, or the value right in the center. Okay, and the next part is asking for the error for this. So that's the distance from the middle to either of the endpoints. One way to figure this out is if you have a calculator, you could take the larger number in the interval and subtract off the middle, and that would tell you the error of it. So let's see, I'll do 23.696, and I'll subtract the mean, which is 23.650, and I get this number, which I'm not going to round, but it's 0.046. And all that tells you is if you're at the middle of this interval, if you go 0.046 in either direction, you'll get either of the endpoints of the interval. Okay, so now we're supposed to interpret the confidence interval. And let's see, it's going to be either A or B because it's the idea of one can be 90% confident, and it's going to be option A for me. So we are 90% confident that the mean age falls within this interval, so between those two values. Okay, and part C is just having us verify the numbers, the endpoints of this interval. And the way this works is you have to start at the mean, and you're going to either add or subtract a number to get the endpoints. So it's asking us to start with the lower bound. So how do you go from the middle to this lower bound of the interval? And so the way it works is, well, first here we're going to enter in the mean, which is 23.650. Okay, and first we're going to subtract because we're starting in the middle and we're going down. And the amount that we're going to go down by is, okay, well, right here we need to get a critical value for t that represents 90% confidence. So what I'm going to do is, instead of using this table, I'm going to open up StatCrunch. So let me bring this down. Okay, what we're going to do is go Stat, go to Calculators, and here we're using a t-distribution instead of the normal distribution. Okay, what we want to enter is a few things. Well, first, I'm going to switch it to between. And since we're talking about a 90% confidence interval, the value that's going to go here is going to be 0.90. The other thing that we need is the degrees of freedom, which will be 1 less than the size of our sample. So I'm basically just going to subtract 1. This will become a 59. So my degrees of freedom are, okay, we got 2, 6, 0, 5, 9. If I click compute, I have this value here and this value here. This one is already negative for me, but what I'm going to do is enter. Let's see. It says round to 3 decimal places as needed. So in this box, I'll put 1.645. Okay. The next thing is we're going to have this value, which is the standard deviation, and we're going to divide by the square root of n. So that is, we're going to divide by 26060. And we could do this on a calculator. I mean, it should be equal to our lower bound. So I'm just going to quickly check this in a calculator. I'm going to do this computation. And let's see what we get. And when I and divide by the square root of 26060. Okay, we do in fact get this lower bound, so that is going to be 23.604. And the upper bound is going to be analogous. The only difference is we're not going to subtract this number. Instead, we're going to add it. And what that is doing is it's telling you how far you go to the left and to the right, so you collect 90% of the data. So this will be, okay, that's going to be 23.650. This time we'll add. I'll add on the same critical value. It's going to be 1.645. We're dividing that standard deviation by the square root of n, which is this number. So 26060. And that value will take you to the upper bound, which should be 23.696. So these are the formulas that determine the confidence interval. And the last thing here is, why is the margin of error for this confidence interval so small? Which it is a pretty small value. And between these options, I think the one that makes the most sense would be the sample size. This is quite a large sample, so that would definitely reduce the amount of error. And I'll check my answer. And that is it for this problem.